Okay, good evening, students. Yesterday we have reviewed the prime number, composite number, and HCF. So I left there, and now we are going to start with the LCM. The numbers which I have yesterday taken an example as 18 and 24. So, and we have got the number as 6 as the HCF or GCD. As you told yesterday, greatest common divisor or highest common factor. Now, what is called LCM? LCM. LCM is called least common multiplier. Multiplier. Okay, sorry with my language. It is called least common multiplier. This is called. Now we are going to find out the LCM of 18 and 24. Okay, so HCF has been arrived at 6. Now we are going to arrive at the LCM of 18 and 24. So, yesterday I told you how to find the LCM, that is the least number, that is 2 into 3 squared, 3 cube into 3, I think, yeah. So 3 here and 2 comes here, least power, this is least power is 1, here least power is 1, so 3 into 2 is 6. This is how we arrived. Now, the same 16, 18 and 24, 18 is equal to 2 into 3 squared. Okay, 24 equal to 2 cube into number, what is that? Into 3, yeah. 2 cube into 3, that is 3 squared is 9 into 2, 18. 2 cube equal to 8. 8 into 3, 24. Is it clear? So, why? Now, what is called the least common multiplier of this 18 and 24? Now, what the book says and what is the procedure says. LCM is the product of prime factors with highest power. So, LCM is the product, here what he using, product of highest power. Highest power. Is it clear? Now, this is the highest power 3 squared. This is the highest power 2 to the power 3. Now let us multiply. This is 9 and this is 3. Sorry, this is 8. 72. So 3 squared is 9. 2 to the cube is 8. 9 into 8 is 72. Okay. So this 72 becomes the least common multiplier. LCM equal to 72. Is it clear? Now, the problem with the student is the highest common factor is 6. Yeah, 6. The least common multiplier is called 72. So, highest is 6, the least is 72. See, that is the confusion between the students. That is, here, if you take 18 and 24, this 6 divides this number. Okay. Here in 72 case, this is 18 and 24. This 24 is divided by 18 and 24 and you get the result. So this is the least common factor. You got the difference now. This is the divisor. Here, this is the divisor. These two are the divisors. Okay. Here, this is the divisor. This is the dividend. I think I'm clear. So, if you get a confusion of least common multiplier is highest number. If you this is 6 is the HCF, don't get confused. This is a set. So for this set, this is the HCF. This is a set, this is the LCM. So this is the law of LCM, product of highest powers. That is 3 squared into 2 to the power 3 is 72. Here this says least power in the case of HCF. That is the least power is 3 to the power 1 and 2 to the power 1. Stop it. Yeah. Now 72 is the LCM of 18 and 24. And I said this is the least common multiple. That is, there is no any other number lesser than 72 can be divided by these two numbers. That is why it is called least common multiplier. You just check. The less than 72 you cannot divide these two numbers. Okay, so now you take 72 into 2. 144 and 72 into 3 is okay. This again 144 can be divided by 18 and 144 can be divided by also 24. Or shall I write like this? 144 is 72 into 2 by 18. Okay. Already we have got the result of 72 by 4. So 4 into 2 is 8. Okay. Again this 144, 72 into 2 divided by 24. So 3 is equal to 6. So you get an answer of 8 and 6. Previously we got an answer of 72 by 18 is 4 and 72 by 24 is 3. Okay, nothing, this is only for an example. So this 144 can be divided by 18 and 24. Again 216 can be divided by this 18 and 24. Okay. This 72 and 1 is also the can be divided by this 18 and 24. Okay. This is why it is called least common multiplier. This is 2. This is 3. So this is why this one is the least. So this is the meaning least. Okay. That is why it is called least common multiple of this 18 and 24. Are you clear? Now we have arrived at HCF and LCM of 18 and 24. 18 and 24 is HCF is 6 and LCM is 72. This is how you should get HCF and LCM of these two numbers. This is a group. So this is the way you should arrive. Okay. Now there is an important theorem on HCF and LCM. This is important. That is, the HCF and LCM, if you multiply, that gives the product of the given numbers. So we have find out the product, that is the HCF and LCM of this number is 6 and 72. Okay. So if you multiply this 24 and 18 and 72 into 6, this will come to 432 and 432. This is the law of in HCF and LCM. So with this, you will have a lot of questions. What they will do? They will not give this. Say they will say X. So from this you can find X. Or they will not give this number. So you can find out with this equation. In exam, they will not give one number. So with this help of this equation, you have to find out the other number. Okay, so this is the number one theorem of HCF and LCM is equal to the product of the even numbers. So the questions will be asked in this kind of this theorem with the based on this theorem. Okay. Now the second one says this is also very important. This will be asked in many CBSE exams. HCF divides LCM completely. Completely. Okay. What it means? See, this LCM is 72. LCM is 16. This is equal to 12. Okay. So if you divide this LCM by HCF, you should get a result without any remainder. Remainder should be 0. It should be completely divides. So HCF divides LCM completely. There are two things. This is number one. This is number two. These two are very important in finding out of the HCF and LCM. There will be questions will be asked in this. There will be questions will be asked in this. They will not give one number. You have to find out the other number. Okay, next, Euclid division of Lemma. This is also connected with our HCF and LCM. What it is? Now let us go to an example. Before I give the theorem, I will first give you the example, then I will go to the theorem. Then only you will understand. Okay, this is simple. Suppose you are going to divide 34 by 5. Okay, this is the quotient and this 34 is the dividend A, this 5 is the divisor B, this 6 is the quotient Q, then the 4 is the remainder R. Are you clear? What is A? A is the dividend, B is the divisor which divides this number, the 6 is the result you are getting from division is the quotient, the 4 is the remainder after doing the division, this is the remainder. Okay, now Euclid's division of Lemma says let A and B any two positive integers, then there exist unique integers Q and R such that A equal to B into Q plus R, where 0 is less than or equal to R is less than B. What it means? Now we will come to this point now. Now this A, this is the dividend. A is 34. Okay. So B is equal to, so this is B is 5. Q is the quotient 6. Okay. Plus remainder is 4. So that means 30 plus 4 is equal to 34. That is what it says. Okay. This theorem is this. So can we correlate this now? So this is called the Euclid's division lemma, where again there is a condition. Here the B is should be greater than R. That is, this B is should be greater than R. See what it means is, if this is 6, you can again divide by 6. So this what this B is greater than 6. You got the point now. So this B should be greater than 6. But here this R is less than 5. So first of all, this B should be greater than 6. Again, this R can be 0 or R can be greater than 0. Here, this is R 4. This is greater than 0. This 4. So this is the condition should apply. That means B should be greater than 4. Suppose why I tell you means if this is 7, you can again divide by 5. That is why it says B should be greater than 6. Okay, now with this theorem, Euclid's division of Lemma. See, I am not able to exactly spell this or pronounce this word. Okay, it's not a problem. Using this theorem, you can find the HCF of these two numbers, that is 273 and 119. In the last section, we have taken 18 and 24 and we have found out 6 is the HCF. But here, these two numbers are big. So we have to do division and division and find the last and common numbers of these two division, and you have to find out the division by this method. The last method I have told you. But now there is the easiest method that this theorem has given. See how you have to do is first you between these two numbers you take 273 and you divide by 190. Okay. So what it comes 119 into 2 is 238. So if you minus it, this will come to 35. Now, since that, now you should always check this reminder. Now what happens? This is the divisor. Now this 190 should come here. Now you divide this 119 by 35. So 119 by 35 is 3 is the quotient and 105 comes 3 into 35 105. Then this is the remainder. Again the remainder is not 0. Now you bring this 35 here. Again you multiply this 35 by 14. So you get 28 and the remainder is 7. Again you put this 14 here and you divide. Now see 7 into 2 14, the remainder is 0. Now the whole thing ends here. Then this 7 becomes the HCF of these two numbers. This is with the Euclid's division of Lemma as devised this way to find out the HCF of two numbers. This is another method. Can you see and can you understand this? Very simple. You divide, find out the remainder is, final remainder is 0. Then the last number which divides this number should be the HCF. This is the highest common factor of this 273. If you divide this 273 by 7, so 3 into so 21, 63, 9. So 9 into 7, 63. So this divides, this is 39 is the answer. So this is okay. Now you divide 119 by 7. So 7, this is 49. So 7 into 7, 49. Again 17 is the answer. So this number 7 divides this both numbers. So this is another way of finding the HCF of these two numbers. This is a set of numbers by using this theorem. Okay, now she is my granddaughter Bhumija. She is recently entered into the exam of CBSE 10th and she is confident of getting more than 75 marks in this recent exam CBSE. So now I am just trying to give a chance how to explain this this example now. So she will now give an example. She will now demonstrate how to solve this problem. I will give it to her now.
So here the question is, if the HCF of 10 and 55 is expressed in the form of 55x minus 325, then find x. So here we should find the value of x. So they have given the two numbers as 210 and 55. So we should find the HCF, and then we should find the HCF of these two numbers and then equate it with this formula. So you should take this as a dividend and take this number as divisor. If we 55 3s are 165 and the remainder becomes 45. Here this divisor becomes the dividend and this becomes the divisor. So 45 ones are 45, the remainder is 10. Then this becomes the divisor and this becomes the dividend. So 10 fours are 40, the remainder is 5. Then this 5 becomes the divisor and this 10 becomes the dividend. So 5 twos are 10 and then the remainder becomes 0. So this 5 becomes the HCF. So then we have to equate 5 is equal to 55x minus 325. So let us take this to this side. So 55x is equal to 5 plus 325. Then 55x is equal to 330. Then x is equal to 330 divided by 55. Then we get x is equal to 6. So the value of x here is 6. Thank you.